So in order to create this effect, initially I have a sphere, and this sphere just moving in this direction, as you can see. Just a quick move. Maybe we can make it go a little bit to this side. Good. So we will create an ocean, a flat tank. Nothing is selected. Enter. So we have our flat tank, and we have initial node, the fluid outcome, and the fluid interior, and the dog network. So here and go to the flat tank and make it a little bit bigger. I want to visualize the other. So it's a little bit extended. And maybe I can extend a little bit more here and minimize it here so it can sim quickly. Okay, so if we go to the Autodock network, this is a narrow band, so it will sim fast. If we play it now, nothing is happening because we have no velocity affecting it. So let's create a custom velocity. First I will create a trail sub, and in the create sub, compute velocity. Now we have some velocity. Good. So we have a V. So let's create a null. We call it vel, and control 1. We go to the dot network, and we create the volume source for now, and we will connect it to volume velocity. And the subpath we will point to that out velocity, and the operation is a vector, and we call it called V, and we convert it to vel. So let's have a look now. And nothing is happening. If we increase it and we check the velocity, so what we will do, so this V will convert it to a volume. So VDP from polygon. Let's try this one. We are not interested in SDF or the volume, we are interested in the V, and we will call it V and set its placement. Let's go here and check again. Now we can see it. A little bit bigger so we can see. And it's moving chaotically, so we will mask it now. We will have another look. Here. So what we will do, we'll apply a mask. The mask will be the surface. Maybe we can decrease the volume here, increase it there. Let's see now. very uniform. We will start to play with it a little bit more. Okay. Sorry. So this is the trail. We'll do bolt bob, and I will visualize the velocity, make it a little bit bigger. Visualization, guide, scale, vector by 5. Okay, we have something. Let's go here, and this is the velocity. We'll go to velocity, so nothing is happening. What I'm interested in also, the y and the z. I want to play with the z, so vector to float, so we can separate it and start to play with it, and then float to vector, so x with the x, y with the y, z with the z. We go here and nothing is happening now yet. So what I want to modify now is the z. I will multiply the z with the normal. I'll take the z and then replace it here. Let me switch. Okay, so I have something different now. If I add a constant, in this constant, let me increase it. Okay, so I will do the cross product between the current velocity here and this one, and the component I will add it here. Now this one is a vector, I must convert it. Yeah, so I'll take this one, sorry, this vector. I'll take the cross product of this one, and I will take the component of this one and add it here. This is the normal of the velocity. Take the position. Okay, let's go to 2. Let's see. Something different now. Let's visualize it. Like a rocket flying through the surface of water. I will do 100 frame. Let me remove the velocity, watch again, and this velocity also. I want to increase the force down also, and it will lift it up. If I took another angle, so let's play more with the velocity. I should create, let's say if I put this one also here, I want to create some randomness, so and alias noise, and this noise, let's add it here. Maybe we can, here I will add it here, so a noise, on the position, frequency is here, maybe I can do something also here. I'll do attribute triangle, at n equal at n, at v equal at n. So the velocity should be, do I have velocity here? Yes. So the velocity is represented by the normal. So we'll go here, or computing velocity also. No need for this one. Cancel. Do I have velocity? Yes. Here. Let's examine where we at now. I need to increase it, multiply it. So we'll add a multiplier. Instance, let's go by 10. So 10 is very high. Let's go by 2. What else we can do? So we have something here to play with. The noise, make it 30, and I want to create constant, 3D constant. Here I want to make it -2, and I will add it to the multiplication. So it's going inward. Let's add some noise to it. Random. This position, it will be multiplied. This one. So we have some random movement. Let's play a little bit with the cross product. So I want a cross product between the normal, or it's the velocity now, to the velocity and a constant. It's added to the velocity, so it's rotating. If I make this one 1 and 0, so it's up and down, and this one will be included in the multiplication, and the product will go to the velocity. Let's see now. I think I will just modify the movement of the sphere because it's very high here, so it's taking time to land. So sphere transform at the beginning, get closer, maybe a little bit more closer. And go to 2. Here I will 10, let's make it 20, see? It is high to 15. If I use ball instead of add, it will be smoother acceleration strength back to the top acceleration strength. So directional strength, let's make it 15. Is very high, so make it 10. Take this high, so 5. This is how fast it will match the velocity of 15. Maybe we can play a little bit more. What else we can do? So this is the cross product. Let's multiply at the end here with the normal, with the normal, and the normal. Let's see what will it give us. Here the normal is between 0 and 1, so let's multiply it by a constant, or not by a constant, by a random number from here, and this one will have a constant that's here. let's make this one taller. And make it 0.1. We have more details. So this one is too high. I'll go down to 10. Now the last step is to the static object, and this static object will use the sphere, the box, and we will use as deforming geometry so it can collide with this one. I want this one. Nice. See, the randomness is affecting the shape also. What else we can do? Let me hide it. Here in the volume collision, we make it 5. So you can see the difference, more pronounced. Where it left off. Good. So 0.1, 0.05, so it's more dense, and we will cache it. For the cache, I go to the out, I write here fetch. I should save it first, I didn't save it. Okay, so in the fetch I will point to a compressed cache. So here in the fluid tank, in the compressed cache, we choose the cylinder, so it will do it. After that, we'll do the surface. The surface we will make it open, not a closed boundary. Okay, we fill the geometry. For resolution, none. So this will make it even slower. Here I'll make it 50. Influence scale of 2. And what else? we'll create another fetch. In this fetch we will take the surface cache, this one. Other thing here, I need to go and check behavior, seeding, separation, droplet. I need droplet, vorticity we need it also, volume limit, collision make it 5, viscosity no need, density no need, divergence, surface tension and solver. So this one, adaptivity, will not waste time on not important areas. Maybe just make it smaller a little bit. Okay. So we'll do the white water now before we cache it. So I'll press on white water. I'll choose the flip tank and press enter. So white water is done. Let me take this, Ctrl C. So this is the white water, and this is the source, and this is the red tank, or this is the outcome. So in the source, here I need to change where it is pointing at. Is the flow tank, and I will add a null here. It can point to it, because already I'm caching this one before the cache. Let's give it a second. Okay, see, it's pointing to the cache. I'll just put it here. I'll leave these the same. Acceleration, let's go 20. Viscosity and volume, output volume. Okay. The white water simulation, I'll add my nodes. Already the gravity is built in here. White water, color, particle by depth. Here we are 0.01. Let's make it 0.025. So behavior emission amount, make it 2 to increase it. Limits is the same. Forces, because that tiny. So this is where is the gravity and buoyancy. Let's make it 40. Here I'll just a little bit and make it go up faster. Foam, variable stiffness and erosion, we'll keep it here. Stiffness depth, a little bit more, XL, size 1.5. So I'm gonna go here. I will cache it. We'll do 5 cache. In the 5 cache, we will call it white water import. Do another fetch. And here we'll select the white water. This one, same name. Render. So we will sim it and we'll come back. So caching is done. This is a quick flipbook. It's low res, needs a little bit more adjustment here and there, just showing the procedure. So you can see this is the foam, and this is the spray and splashes, and below it should be the bubble, but because the sphere is just affecting the surface with velocity only, so very less bubble. Okay, so see another view. It will look nice from a distance. Okay. And this is another view. As you can see, the foam and the gaps is being expanded. So we will create now, let's choose equity frame. Something like this. We create a camera. Just cut it like this. Okay, so we choose this frame, we create environment light, and we'll add, let's say first, let's add an HDRI for it. We'll click the positive hemisphere. Here we choose karma, choose the camera, and let's kick it. See an overview. Now it's converting it to USD. We choose our camera and choose karma, and wait for it till it finishes thinking. Already you can see in the viewport the texture is already applied. That's nice. So this is how we create an interaction between a sphere and flip tank. Thank you for watching.